Hi everyone, this is Ashwin again. How is it going? Welcome back to my series of tutorials on OpenCV 3 and Python 3. Till now we have learned a lot of image processing with OpenCV, NumPy and Matplotlib. From this tutorial onwards, we are going to get started with basics of arithmetic operations on images. So as all of us know that images are nothing but numbers. So let's open a notepad. So we all know that images are numbers, right? So we can draw correlation between the numerical arithmetic operations and arithmetic operations that we perform on numbers and arithmetic operations that we perform on image. So the usual arithmetic operations that we perform on numbers are addition, that's plus, and subtraction, minus, division, that is divide, and multiplication, that is star. Okay, so we can perform all these operations on images, and let's see how the images look after we perform these operations on the images. So this is the earlier program that we used for demonstrating plt.subplot function in Matplotlib. Let's execute it once again to see if it is working correctly or it has broken down. So programs are not supposed to break down all of a sudden. So the program is working fine and it is showing two images, liquid drop as well as Lena, in a single Matplotlib window. Now we are going to add two images. Just pay attention what I do. So I'm just going to add two titles. Should I add an additional title? Add. Okay, and let's say add equals to img1 plus img2. So add equals to img1 plus img2. So that is going to add two images. I also need to make some changes in the code which is used to display the images. So here I will use three columns of images. I mean the grid size will be 1 by 3 rather than 1 by 2. So now when I execute this program, you can see the images of liquid drop as well as Lena have been added to each other, and the variable add, right? It contains the final result of the addition. So I will just say addition, ADDITION. Okay. So this is going to be more appropriate level. We can the same way we can even have subtraction, right? SUB equal to img1 minus img2. We will just label it as img1 minus img2. So I'm going to tell you the reason I'm using this particular label. And SUB. Yeah. So here we are going to make change. And let's execute this code to see the output. Yes. So here I'm subtracting image 2 from image 1. And you can see the result is kind of different than addition. Now, as all of us know that subtraction and addition, I mean what these operations mean. So let's take a numerical example. So 2 and 3, these are two numbers, right? So whenever I add whenever I add number 2 to the number 3, the result is going to be 5, right? Sorry, it's 5. And whenever I am going to add 3 to the number 2, again the result is going to be same. But it is not the same case with subtraction operation. When 2 minus 3 equal to minus 1 and 3 minus 2 equal to 1. So essentially, if you are aware of mathematics or if you have taken any sort of mathematics course during your graduation, grad studies or undergrad studies, you will understand that I am talking about commutativity. Commutative. Okay. So addition operation is commutative, but subtraction operation is not commutative. So even the operands are same, right? If you change the order of operands while using the subtraction operation, the result is going to be different. So we are going to see the demonstration of that here using images. This is like a very real world example of commutativity, how this commutative stuff works. SU, just say img1, and we will just say here sub1 comma sub2. The same way we can even say img2 minus img1 minus img1. Finally, we are just going to make a change in the piece of code which displays these images in a row. Now let's execute this code, and as you can see, there is a difference between the outputs of img1 and img2. Let's execute the code again. Yes, the difference is quite apparent, right? So it is different basically. So now if you're really interested in knowing how this arithmetic operation or any arithmetic operation works, we can just take the analogy of matrix. Basically, it's not like even analogy, but it's whenever you add any two images, we are just simply adding the respective matrices. So if it is 1, 2, so this is the matrix 1, and then this is matrix 2. Suppose this is matrix 2, 3, 4, 5 and 6. So the output of this thing is going to be, as we all know, 4, 5, 4 and 6, and 6 and 8. The same way, consider that this is an image. So if this is image 1 and this is image 2, then the output is going to be something like this. And it works in the same fashion with subtraction operation. So now we are going to have a look at how how this addition and subtraction works when it comes to plain numbers. We can just so let me save this piece of code, save as, okay. And we are going to experiment with a couple of new things which you might be surprised to see how these things work. So if I'm just going to say add equal to img1 plus 5, and let's see what the output is going to be. So okay, so whenever I just add a number 5, what it means is that it adds number 5 to every channel of all the pixels here. I can even add, say, 50, and we are going to see what is the difference, because 5 is such a small number, and 0 to 255, it's a range of almost it is the range of 256 distinct values. So adding 5 to every number might not make a big change, but if we add a really big number like 50 or 100, it might actually create a noticeable change in the image. So let's see what it does. See, I have added 50 to every pixel and every channel of every pixel, right? So it is producing this output. So this is the original image, liquid drop, and this addition is the output when I'm adding 50 to that. Same way we can subtract 50 from the original image, and let's see what the output could be. Yeah, so when I subtract 50 from the original image, this is what it looks like. The other way we can work with that is, let's say 50 minus img1, and let's see what the output could be. Yeah, so the output is different even in this case. So this is how we are considering a matrix which contains 50 as all the numbers, right? So in case you are not comfortable with this, we can even make this something like 50, 50, because this is an RGB image, right? 50, 50, 50, and let's see what the output is going to be like. Okay, so I guess it doesn't work that way. Okay, it doesn't work. It doesn't seem to work that way. We are just going to keep it 50. So it is going to add 50 to almost all the channels, right? All the channels as well as all the pixels. So every element of this matrix img1 or image img1 is going to be added with 50. So this is how basically addition and subtraction operations work. Now let's get into something more interesting, something like multiplication and division. That would be a great idea. So let me save this thing as a new program, because we might actually want to explore something new for which we have to delete the earlier code. Let's create a variable known as multiply, MULT, and div image 1 into image 2, img2, and let's see what the output looks like. So this is nothing but three-dimensional matrix multiplication. So the result is going to be quite interesting. Multiplication. And finally, it should be division. division. So in case you are interested in seeing the raw values of the matrix, you can just print that matrix to the console. So in this, we are going to print that matrix to the console. Just say MULT and div in the images. Div. Yeah, now it looks cool. I just need to delete this line because this is not necessary anymore. And let's change the code which displays the stuff. Okay, so here I guess I need to make some changes. img1 divided by img2. And just like addition and subtraction, there is a difference between commutativity of multiplication and division. Multiplication is commutative operation, division is not. So img1 into img2 equals to img2 into img1. But img1 divided by img2 is never going to be equal to img2 divided by img1, correct? So let's cross the fingers, and because I'm executing this code very first time, so to be very frank, what happens I don't know. So I hope the computer is not going to hang, because my computer is quite powerful. It should be able to handle 512 by 512 into 3, that sort of matrix multiplication, three-dimensional matrix multiplication and division. Yeah, so the multiplication looks something like this. The liquid drop into Lena equal to, we are getting some noise sort of stuff. It's not noise actually, because the pattern is quite consistent. And the division looks like something like this, but the images do not make any sort of sense for any one of us. So yeah, we can even multiply image with a number, just the way we added 50 to the earlier example. So I'm just going to multiply the first image with 2, and let's see what the output is. Yeah, so multiplication looks like this, right? And division, let's divide it by 2. And let's see what is the output. Yeah, so multiplication looks like this, and the division with a simple number looks like this. We can probably multiply it by some fractional number, but anyway, this is the constituents of liquid drop image, right? So the members of that matrix, they are nothing but unsigned integers of 8-bit, so they can just represent 0 to 255, so they can't represent any decimal point. But if we multiply it with decimal point, it is probably going to truncate the decimal point, and it is going to give us an output. So let's see what it looks like. Yeah, so multiplication looks like it's even more weird. And let's see how the division works when we use 1.5. Yeah, division even looks more weird. So this is how we can use multiplication and division on numbers. So in this tutorial, we learned how to add and multiply images. We also learned how to subtract and divide images. We also change the images, one of the images with a number as an operand, and we saw how we can add and multiply numbers to the images. And this is how basically pretty much all the arithmetic operations on images work like. So you might be wondering what is the utility of all these arithmetic operations. So in the next tutorial, we are going to see what weighted addition looks like and what we can accomplish with weighted addition. Thanks a lot. Let me know your thoughts and suggestions in the comment section. Don't forget to like, share and subscribe. I will see you next time.